What is it? Sex-linked genes reveal a unique pattern of inheritance, and besides having genes that just determine gender, the sex chromosomes also have genes for individuals different from femaleness or maleness. An example of a carrier female would be capital X, capital H, capital X, lowercase h, and an example of an affected female would be capital X, lowercase h, capital X, lowercase h. An example of an unaffected male would be capital X, lowercase h, capital Y, and an example of an affected male would be capital X, lowercase h, capital Y. And sex-linked disorders are more common in males because they do not have the same backup chromosome that females do. So in this example, if they get at least one lowercase h allele, they will automatically have the disease, whereas if a female were to have one lowercase h, they would just be a carrier and they wouldn't actually have the disease. Sex-linked inheritance sample problem. Two normal vision parents produce a colorblind son. Draw a pedigree that includes every person mentioned in the story. Include a Punnett square of the parents. So after reading the story, we know that the son is colorblind, so we can just label that here on the pedigree. And we also know that the parents are unaffected and normal, so we can label that here as well. So now looking at our genotype key, we see that an affected male is X lowercase h y. So we can write that in our pedigree right here. So now we have to figure out what the genotypes of the parents are. And since we know that they are both normal visioned and unaffected, we can rule out the affected genotype. And since the father cannot be affected, this means he has to be healthy, so his genotype is automatically X capital HY. So now looking at the mom, we have to figure out if she is a carrier or if she is healthy. So now looking back at the son, we see that he has a recessive gene on the chromosome. So the mother cannot be healthy because if she was healthy, she wouldn't have the recessive gene. So this means she has to be a carrier. So now we can go fill out our Punnett square. And on the top we have a carrier mother, and on the left we have a healthy father. After filling it in, we know that we have a healthy female, a carrier female, a healthy male, and an affected male. So knowing this, we can tell that the genotypes are X capital H, X lowercase h for the carrier mother, and X capital HY for the healthy father. So now we can just fill in our pedigree with that information to complete it. So question B asks, what are the chances of their next child being a colorblind daughter? So if we look back at our Punnett square, we see that they only have 2 daughters, and there's a 0% chance that they will be colorblind because the daughters are healthy and a carrier. Question C, before having this first child, what is the probability that this couple will have 3 children all healthy? So going back to our Punnett square, we see that these are the 3 healthy children, which means that there is a 3 out of 4 chance that their child will be healthy. And in order to figure out if their next 3 children will be healthy, we have to multiply it 3 times by itself. And that gives us 9/64. And that is the probability that they will have 3 children all healthy. Patterns of Inheritance, Biology Honors, Period 7 by Mia Wilson.